Here's something that will either seem obviously true or completely impossible, depending on how you think about math. Every single human alive today, from Stockholm to Sao Paulo, carries genetic material that traces directly back to one woman who died roughly 150,000 to 200,000 years ago. Not because she was special, not because she was the only woman alive, not because she led some grand exodus or had particularly good genes. Just because statistics, probability, and time work the way they do. She's called Mitochondrial Eve, which sounds like a Marvel character and is, in fact, considerably more interesting. Let's start by clearing up what she actually was, because the name creates an almost irresistible urge to imagine a solitary figure standing alone on a prehistoric ridge, waiting for humanity's destiny to begin. That's dramatically compelling, completely wrong, and exactly the kind of thing popular science does. Mitochondrial Eve wasn't the first woman, the strongest woman, or a woman who did anything particularly noteworthy. She was a woman somewhere in Africa who happened to have daughters, and her daughters had daughters. And for roughly 150,000 years, through an almost absurd chain of probability and survival, the maternal lineage never broke, while every other maternal lineage alive at her time quietly went extinct. Before we go further, subscribe to Passpoint, because the next part involves DNA and how scientists trace genetic inheritance backward through time like the world's most patient cold case detective. Mitochondria are small structures inside cells separate from the nucleus with their own DNA. They're basically cellular power plants, converting glucose into usable energy, and critically, they're inherited almost exclusively through maternal lineage. Your mother gave you mitochondria, your father's mitochondria died inside his cells and never got passed on, which, from the perspective of genetic inheritance, means fathers are an evolutionary dead end for mitochondrial DNA. This matters because mitochondrial DNA mutates slowly, creating a genetic clock. Scientists can track mutations and calculate how long ago different human populations shared a common maternal ancestor. Follow that chain backward, and you eventually reach a single woman whose daughter's daughter's daughters, repeated hundreds of times, led directly to every human alive today. That woman lived somewhere between 100,000 and 200,000 years ago, depending on which mutation rate estimates you trust. Researchers have located her most probable origin in Africa, though the exact location remains debated, because genetics doesn't pinpoint like an address, it whispers like a rumor. If you're enjoying this uncomfortably humbling origin story, subscribe to Passpoint, because the next part involves the wildly unlikely chain of events required to create a bottleneck this extreme. Mitochondrial Eve wasn't rare because she was special. She was rare because every maternal lineage except hers went extinct. Think about that for a moment. Right now, at this exact instant, roughly 4 billion women are alive. In 100 years, statistically, roughly 0% of their maternal lineages will survive to human extinction. Most of you reading this already know your maternal line will end with you or a relative who chose not to have children, which is completely fine, but it does mean your specific mitochondrial DNA stops here. The women around Mitochondrial Eve faced the same math. They had daughters, granddaughters, great-granddaughters, and somewhere in that chain, a line went childless, or had only sons, or had daughters who themselves had no children who survived to reproduce. Over thousands of generations, with groups splitting, moving, sometimes facing population crashes that nearly wiped out entire settlements, the survival of any single maternal lineage became statistically improbable. Mitochondrial Eve's lineage survived anyway, not because she was smarter or stronger, but because she happened to live in a stable enough place with stable enough descendants long enough for the statistics to work in her favor. This is where the common misunderstanding arrives, usually in the form of someone saying, "So, everyone came from one woman?" Which sounds like isolation and founding events and controlled breeding, none of which is remotely accurate. Mitochondrial Eve was surrounded by other women, thousands of them. The population of Africa in the Pleistocene wasn't a handful of people clustered around one woman. It was communities, groups, networks. But all those other women's maternal lineages eventually died out, while mitochondrial Eve's didn't. It's the genetic equivalent of asking, how likely is it that all humans today are descended from someone named Eve? The answer isn't very, it's inevitable, because every population has a mitochondrial Eve, and the only reason you're hearing about this one is that she's yours. Put all of this together, and mitochondrial Eve stops being some mystical founding mother and starts being something almost mathematically boring. A woman who lived 150,000 years ago and had daughters who survived long enough to pass on genes, a chain that broke in every other maternal lineage but somehow held in hers. Which brings us back to that opening claim. Every human alive today carries her mitochondrial DNA. Not as some miracle, not as evidence of special status, but as the inevitable result of one maternal line surviving when others didn't. You're not special because you're descended from mitochondrial Eve. You're descended from mitochondrial Eve because you're alive, and staying alive long enough to reproduce requires, generally speaking, not going extinct. If this changed the way you think about human ancestry, subscribe to Past Point. Somewhere in your DNA is proof that for 150,000 years, a chain of women chose to have children, and the universe allowed at least one of them to have daughters, which, honestly, is enough.